Good evening, students. This is my seventh or eighth video. Seventh or eighth video. Today we have to discuss about the isothermal irreversible expansion of van der Waals gas. We already discussed about expression for W, expression for U, and expression for Q. Today we have to discuss about isothermal irreversible expansion of van der Waals gas, expression for H, enthalpy. That means we have to discuss about isothermal irreversible expansion of van der Waals gas, small v n van der Waals, capital W, van der Waals gas. It is isothermal, means temperature constant. Irreversible, that means whatever occur in our nature, all are irreversible, nothing is reversible, all are irreversible. Burning, whether you burning something or whatever you do in day-to-day life, all are irreversible. Expansion means from lower volume to higher volume, that is expansion. Suppose 3 liter gas is, you convert it into 5 liter. Okay, that is called expansion, 3 liter to 5 liter. A van der Waals gas, that means real gas. We already discussed about W, work done. We also discussed about delta U. We also discussed about the heat Q. Now we have to expression for enthalpy. It's the same value it will come. Like the reversible process, it will the same value. Nothing change. But we will derive this one expression for Q. Let initial case enthalpy is H1, U1, pressure is constant PV1, it is initial. Suppose in the final state what you do, now H2, U2 plus pressure is constant PV2, it is final state. What is the change in enthalpy? Final minus initial. That means you will get H2 minus H1, which is equal to U2 minus U1 plus PV2 minus PV1. Okay, final minus initial. That means this will be equal to delta H is equal to delta U plus PV2 minus PV1. Okay, now delta H we need delta H is equal to delta U, that is the change in internal energy. We already derived this one. This value will come, delta U is this one, minus n rho square A minus n rho square A 1 by V2 minus 1 by V1, 1 by V2 minus 1 by V1, we already derived it. Then plus PV2 minus PV1. Then we have to find out P, van der Waals equation, P plus n rho square A by V rho square whole of V minus NB is equal to nRT. This is the van der Waals equation. Take this one to the bottom. We get P plus n rho square A by V square is equal to nRT divided by V minus NB. Take this one to this side. Now P is equal to this one to this side, nRT divided by V minus NB minus n rho square A by V square. We need PV to PV1, that means PV. What is the value of PV? Multiply V on both sides, left and right. we get nRTV divided by V minus NB minus n square A into V. 1 V multiply 1 V cancel, then n square A by V. This is equal to PV. Then we want PV2 and PV1. What is PV2? Now PV2 is equal to, in place of V we write V2. PV2 is equal to nRT V2 divided by V2 minus NV minus n square A divided by V2. Now PV1 is equal to nRT V1 divided by V1 minus NV minus n square A divided by V1. Okay, now put this PV2 and PV1 in this equation. We get delta H. Delta H is equal to minus n square A whole of 1 by V2 minus 1 by V1 plus PV2, this one, nRT V2 divided by V2 minus NV minus n square A by V2, PV2 minus PV1, then minus, it will come minus nRT V1 divided by V1 minus NV. Here minus means minus minus plus n square A by V1. Here minus na. Here PV2 minus PV1. Minus PV1 means minus. Here minus minus plus. Take this one to the side and this one also to that side. Then your delta H is equal to minus n square A 1 by V2 minus 1 by V1 plus nRT, take common. From this, these two you take nRT common. What you get? V2 divided V2 minus NV, nRT common. Then V1 divided by V1 minus NV. Then in this 2 take n square A common. N square A you take common, you get, here you take minus. When you take minus, you get n square A minus 1 by V2. 1 by V2. N square A minus V2 minus n square A V2 minus n square A V2. Then here is, you take minus, so here is plus, so minus, you put here minus because minus minus will plus 1 by V1. Take this one, n square A 1 by V2 minus 1 by V1 minus n square A 1 by V2 minus 1 by V1. This one mixed, we get minus 2n square. Then delta H is equal to minus 2n square A 1 by V2 minus 1 by V1. Then plus nRT whole of V2, you take plus n minus NB plus NB. Then NB cancel, same thing we get, no problem. V2 minus NB, minus V1 minus NB plus NB minus NB plus NB divided by V1 minus NB whole bracket. Now split this one, V2 minus NB divided by V2 minus NB plus NB by V2 minus NB. Same thing happen here also. Okay, same way, no problem. Same way, same answer you will get. That is why in the note it is not mentioned. The same way, same result. 1 by V2 minus 1 by V1 plus nRT you take common. I make square bracket here. V2 minus NB divided by V2 minus NB plus NB divided by V2 minus NB, then minus V1 minus NB divided by V1 minus NB, then minus it plus is that, then I put minus because minus minus will be plus, NB divided by V1 minus NB, bracket end, bracket end. Here we take minus my V1 minus NB by V1 minus NB. If you take minus outside, it will minus, when you move it, minus minus plus, no problem, same. Then delta H is equal to minus 2n square A 1 by V2 minus 1 by V1 plus nRT whole bracket, V2 minus NB, V2 minus NB cancel, we get 1 plus NB divided by V2 minus NB. This one cancel, V1 minus NB, make it bracket, otherwise mistake. This is cancel, minus 1 minus NB divided by V1 minus NB, plus 1 minus 1 cancel, we get delta H is equal to minus 2n square A whole of V2 minus 1 by V1 plus nRT. Take NB common. Okay, NB common, you get 1 by V2 minus NB minus 1 by V1 minus NB. Now n square RTB, delta H is equal to minus 2n square A 1 by V2 minus 1 by V1 plus n square nn RTB, n square RTB whole of 1 by V2 minus NB minus 1 by V1 minus NB. Okay, same result, no problem. Whatever you get in reversible, same result also you get in irreversible. Same result will also you get in free expansion. Nothing, same result. That is why in the note it was not mentioned, because same result, same process you will get. This is all about the isothermal irreversible expansion. Now we will go, next step is isothermal, that was we completed reversible, now it is completed irreversible. Now we will do free expansion. Free expansion means when vacuum means pressure 0. So isothermal, same isothermal process, isothermal free expansion of van der Waals gas, small b, small d, van der Waals gas. Anderson was dead just yesterday. He was dead at the age of 96. He got Nobel Prize in physics using the condensed matter physics. Condensed matter physics they used, and they discovered that electron is localized in case of the insulator. They also find out conductor, insulator, superconductor, basically used treated with the condensed matter physics. He named it Anderson at the age of 96. Yesterday he was deceased. For condensed matter physics, he also awarded Nobel Prize in physics. Okay, so this is the van der Waals. He is a Dutch, but before that name is there, so small b. Now it will see that isothermal free expansion of van der Waals gas. Then expression for W, same 4 process. Expression for W. We know that expression W, we know that work is equal expansion. That means lower volume to higher volume. When work done by the system. When work done by the system, it will become negative P dV, which is equal to minus P external volume free V2 minus V1. Lower volume is V1, higher volume is V2. But in case of free expansion, P external is equal to 0. In case of when na free expansion. Free expansion means in vacuum. In vacuum, it is also called as vacuum. Vacuum means there is no pressure, no gas, nothing. So pressure is 0. When external pressure is 0, now your W becomes minus external pressure 0. 0 into multiply with V2 minus V1. 0 sum multiply with 0 means 0. So work done, there is no pressure volume work. That means work done, that work done is 0. That means work done is 0. Work done is 0. Just like in case of very high resistance, when it is not possible to work done is 0. And when case of friction is 0, then also work done is 0. In this case also free expansion. Free expansion means into vacuum. So external pressure is 0. So work done also 0. Then expression for U. U means change in internal energy. Change in internal energy. This is same way we will derive and we get the same result. That is why in the note it was not derived. Because same result you will get just like in reversible and irreversible process, whatever be the result and whatever be the procedure, same procedure is also adopted here. I will also do here. U is a function of volume and T. You also do. That means you think that same, so you do not skip it. Because when you do practice, then it will become easy for you. So practice makes a man perfect. So you do practice every time. Without practice, you will do somewhere some mistake. If you do not practice, then what you get? Now differential du is equal to dou u by dou v at constant temperature dv plus dou u by dou t at constant v dt. That will use a function of v and t. Then applying the first law of thermodynamics, applying the first law of thermodynamics, what do we know? Now your del q is equal to du plus p dv. Take dv to that side. That means del q minus p dv is equal to du. That means du is equal to del q. Instead of del q, we know that ds is equal to del q by t. That means t ds is equal to del q. Okay, that means instead of del q, we write tds. tds minus p dv. Then we find that dou u by dou v at constant temperature, differentiate with v, keeping temperature constant, t dou s by dou v at constant temperature minus p t dou s by dou v constant temperature minus p. Applying Maxwell's equation, we know that dou s by dou v at constant temperature is equal to dou p by dou t at constant v. This is the Maxwell's equation. So instead of dou S by dou V, I can write dou P by dou T. So this equation becomes dou U by dou V constant temperature is equal to T. Instead of dou S by dou V, I write dou P by dou T, this one, dou P by dou T at constant V, then minus P. Then P means van der Waals equation. We know that P plus N rho square A by V rho square whole of V minus NB is equal to nRT. Then P plus N rho square A by V rho square nRT divided by V minus NB. Take this one to this side. We get P is equal to nRT by V minus NB minus N rho square A by V rho square. We need dou with this one. We need dou P by dou T. Differentiate with T. Dou P by dou T keeping volume constant. N constant, R constant, V constant, N constant, V constant. So NR divided by V minus NB. Then dou T by dou T, which is cancel 1. Then these are all are constant, minus these are all N constant, A constant, V constant. Then when you differentiate a constant, this value will come 0. Then dou T by dou T is equal to 1. That means dou P by dou T constant V is equal to NR by V minus NB. Now substitute this value here. We get what? Now dou U by dou V constant T is equal to T. Dou P by dou T. Dou P dou P by dou T is equal to this one. Dou P by dou T constant volume. Dou P by dou T constant volume is equal to this one, is equal to NR divided by V minus NB. T dou P by dou T. Dou P by dou T value we get here. Then minus P. P value this one. This is the van der Waals equation. P value minus nRT V minus NB minus plus N rho square A by V square. This one cancel. So dou U by dou V at constant T is equal to N rho square A by V square. Now substitute this value in the first equation. Dou U by dou V constant temperature. Here you see dou U by dou V constant temperature. In this place I put this value, that value in this in that point. Okay, here dt is equal to 0 because temperature is constant, so this fraction will come as 0. The entire portion will come as 0 because isothermal means temperature constant, dt is equal to 0. So I put this value, that means the value will come like this. du is equal to dou U by dou V constant temperature. In that place we write here N square A by V square. Then dV minus plus dou U by dou T plus dou U by dou T constant volume dt. dt is equal to 0 at constant temperature. dt is equal to 0. heck musa ଘୁଞ୍ଚେଇ ଦେଲା ରେ ନାଇଁ ଠିକ୍ ମୂଷା ଯା ମୁଁ ସବୁବେଳେ କାହିଁକି ଆସୁଛନ୍ତି ତ ମୁଣ୍ଡ କାଟିଦେବି ତ ସବୁ ମାଣ୍ଡିଆ ଖାଇଲୁ, ସବୁ ଖାଇଲୁ, ପୁଣି ଆସୁଛୁ ସବୁ ମାଣ୍ଡିଆ ଗୁଡ଼ା ଖାଇଦେଲ। ଅଟୋମେଟିକ୍ କରିଛି କି ନାହିଁ କେଜାଣି, ନା ଅଟୋମେଟିକ୍ ଥିବ ତ ଚେଞ୍ଜ କରିନି। ହଉ ଷ୍ଟାର୍ଟ। dt is equal to 0. So dt is equal to, our isothermal process means dt is equal to 0. When dt is equal to 0 means this one is equal to 0. 0 multiply with something means this one is equal to 0. Now is equal to du is equal to n rho square a by v square dv. Now integrate the equation, integrate du from u1 to u2, then n rho square a is constant, integrate dv by v square v1 to v2. Okay, now we put this value u2 minus u1, this integration value will come you write here u, it will come u1 to u2, then n square a, I can write like this v minus 2 dv from v1 to v2. Here upper limit first, then low limit, then u2 minus u1, you get n square a, then here minus 2 plus 1, my minus 2 plus 1, it will come as, I put here a bracket, it will come as v minus 2 plus 1 divided by minus 2 plus 1 from v1 to v2, then it will come as delta u is equal to n square a, then it is here minus 2 plus 1, minus 2 plus 1 1 minus, it will come as negative here, I write here, then it will come v2 minus 1 and v to the power minus 1, that means 1 by v whole of v1 to v2, then delta u is equal to minus n square a, first upper limit 1 by v2 minus 1 by v1. Okay, that means that is your change in internal energy. Same result, whatever you get in reversible and irreversible, same result also for free expansion, same result, n square n square a. This is the same result you will get, whatever you get in reversible and irreversible, same result also you get in free expansion, no change. Then expression for q, expression for q. From the first law of thermodynamics, we know that del q is equal to del u minus w. That was the, why negative? Because it undergo expansion. Expansion means work done by the system. By the system means system's energy decreases. So that is why negative. Then what is the del q? Now del q is equal to del u. Del u value this one, minus n square a, 1 by v2 minus 1 by v1. This is the del square minus w. Work done in free expansion. Work done free expansion means 0. Work done is 0. So we write here 0. Work done 0 means we write here 0 minus 0. That means del q by only q, when in this one is equal to minus n square a, 1 by v2 minus 1 by v1, that is equal to q. You see that in this case q is equal to del u. Whatever the value you get q, delta u, same value also you get in del q, same value. But in case of free expansion, just like work done 0, during isothermal free expansion, q and delta u are not equal to 0. Like unlike, you can write unlike w, which is 0. जा पड़ा कौन से काटुची मो मांडिया खाइला पुणी कौन से जाउची रह तो मुंड काटी. Unlike w which is 0, unlike w which is 0, q and delta u are not equal to 0, are not equal to 0, not equal to 0, because the system absorbs the system absorbs energy from the surrounding, from the surrounding, absorbs energy from the surrounding. They absorb energy from the surrounding, and that energy is used. This energy is used. This energy is used to overcome the force of attraction. To overcome the force of attraction exist between the gas molecules. Between the gas molecules, because these are van der Waals. Van der Waals means force of attraction between the gas molecules exist, and the volume of the gas molecule is not neglected. That means there exists force of attraction between the gas molecule, and they also exist volume. But when this amount of energy is absorbed, this energy is used to overcome the force of attraction between the gas molecules. That means when this much amount of energy is absorbed, the van der Waals gas tends towards ideal, but not ideal, tends towards ideal. Okay, and that energy, and it is stored. It is whatever the energy it absorbed, it is stored as potential energy. It is stored as potential energy. Okay, now I will complete this one. Next class we have to study about the enthalpy, expression for enthalpy. Expression same like reversible, like irreversible. In pre-expansion also same value you get, same method, everything same. But we will do, because when you make it practice, so you also do practice, never skip it. The same as like reversible, same irreversible, but you practice it, then it will not mistake. Okay, then we will do ideal gas. Okay, now we complete it. Heck Musa, but tu kuan astu manja kayu, sabu kayu, kuan astu jak, but sabu manja kayu na. Order ni manja udah kau, buat पैसा. अरे इधर बंद करनी